will not be in the picture. All right, so what I wanted to do was talk to you a little bit about this number 8, drawing the memory diagram, so you could see the order in which we're doing it, right? And remember, I talked just a bit at the beginning about how a history memory diagram would have crossing out, right? And a state diagram would just have the state at the end. So what I'm going to do right now is I'm just going to probably cross things out so that you can see kind of what I'm doing. And as we do it, I'm going to talk about what is it I care that you have in a memory diagram, because all of you have come from different classes. You're going to go into different classes at different levels. We'll end up using different kinds of memory diagrams, okay? And what I want you to be able to do is understand them in general, because there's only certain things that are really important about each one, right? And the exact syntax isn't as important. What you realize is that's true about languages too. As you get further, right, you'll be using lots of different languages, and a loop is a loop is a loop. It's just what's the syntax for it, okay? So that's what we're going to do right now. We're looking at number 8 in the POGO activity on Java Visualizer. So we're going to draw a memory diagram for this piece of code. So the first thing is that we're going to be in some method, probably main. So in general, you will want to draw things within some stack frame. I haven't given it to you here, but you can assume if it's not given that it's main. Okay? And so I have int width. So every declaration will create a variable. Primitives will always have the value inside the box. And width is an int, so it has a default value of 0. Okay? Score is a double. So what is the default value for score?
0.0.
Right? That's just to let me remember that it's a double. Okay? You wouldn't have to put that in. Input, right? Input is an object. What's my hint that it's an object instead of a primitive type?
Scanner.
Okay, scanner, yes, but look at the first letter of scanner. It's capitalized, okay? So that means that I'm going to use an arrow, okay? And that I'm just going to say is a scanner, and right now I'm just going to represent it like this, okay? Because that's not a critical part of what we're doing here. And then first is a string, okay? Reference or primitive? Shout it out, right, reference. Okay. Other. Okay. I just did something wrong here. What did I do wrong? Have I assigned anything to it yet?
No.
No, right? So this arrow means that it has an address in it, i.e. a number in it. But I don't have that. So by default, references are essentially 0, but they're really null. So you can put null in here. Some people represent that with just a slash through the box. Okay, so I'll also have that here. Okay, now we get to the interesting part, right? So now I know about how many variables I have, so I can close off my box. Okay, so now I say width equals 20. I can cross that out. But when I cross it out, what it means is that it's completely erased, and I have 20 on top of there if there's not 2 values in there. Okay? Now double score is a double, so it's going to end up being 0.94. And of course, you could write it beside the box, and I would understand, but I really want some indication that it's in the box. Okay? Now input equals new scanner, so I should have actually just waited until I see new here. Right? Before I showed that arrow. So with the declaration, I didn't have that yet. I should have just had null here first also. Now, so I'm going to write null and then cross it out to represent that. Okay, because I forgot that. All right, now I say first equals Taylor. When I process a statement like this, what I do is I figure out what's on the right-hand side of the assignment first. And so I should have a string called Taylor. All right? Then what I'm going to end up doing is assigning the address of that, right, to first. So I'll cross this out and say this points to Taylor. Now, this is important, right, because actually this is just a number, this arrow. I could say that it's 45, okay? What happens is just like what happens if I were to say score equals width, right? And I would end up putting 20 into here, okay? I'm just copying a value from one place to the other. So when I copy this value down to here, I just get the same address, and it points over here. So what a lot of people like to do is say, okay, let me pretend that this is address, I said 45. I'll just say that, right? Because I don't know what it's going to be. I'm just picking it out of the blue. Then that means that both of these would actually have 45 in it. I would not expect you to do this, but that's just an explanation of what that arrow actually means. Okay? So now, both of those point to Taylor. What happens when I do Swift, first equals Swift, what I do is I create something down here, right? Let me say that that's 200. Then after I've created it, what I do is I assign its value to first. So now, instead of first equaling, right, that, it's going to have 200 and point down to here, okay? So when I print out other, I haven't changed other, and so it prints out Taylor, okay? So this is why we want you to be able to do these memory diagrams, is because it's easy to alias something. Now, one person asked me, what do I do, how is it that something could get changed? Well, when they're both pointing to the same thing, right, I can't do this with strings because strings are immutable. But if I had a mutator, i.e. a setter or something like that, on this object over here, so let's imagine it's a point, okay? Then I could use that setter to change the object that's over here. And if I do that, then the object that's pointed to by first and the object that's pointed to by other would be changed. Okay? All right, you can stop that.